and I'm in coaching center. So today I'm going to explain your 12th standard chemistry 4th chapter, that is chemical kinetics part 2 video. So last video I stopped here. So let's continue from pseudo first order reaction. So chemical reaction which appear to be of higher order but actually are of the lower order are called pseudo order reaction. In case of pseudo first order reaction, chemical reaction between two SR stances takes place and one of the reactants is present in excess. So this is the formula for it. And so in this reaction, for this chemical reaction, C12H20O11 plus H2O gives you glucose and fructose. So method of determine order of reaction. So graphical method. So it is straight graph. Zero order means you have to write straight graph, and first order means like this it should go, and second order means little bit bent, A2 like this it should go. So graphical initial method. In this method, the order of a reaction is determined by varying the concentration of one of the reactants while other are kept constant. And integrated rate law method. In this method, out different integrate rate equations which give the most constant value for the rate constant corresponds to a specific order of reaction. It corresponds for a specific order of reaction. And half-life period. T1 by 2 you all learned in your last video. Method. In general, half-life period T1 by 2 of a reaction of nth order is related to initial concentration of the reactant as. So T1 by 2 1 AON minus 1, like this you have to write the graph. And here this method is employed only when the rate law involved only one concentration term. So Ostwald isolation method. This method is employed in the determination of the order of complication reaction by isolating one of the reactants so far as if influence on the reaction rate is concentrated. After that, next is Arrhenius equation. So K constant is equal to A by E or T here the log. So logarithm 10K is equal to logarithm 10A minus E by EA by 2.303 RT. A frequency R is the gas constant and here EO is the active energy in this logarithm formula. Next is activated complex or transition state. So activated complex is the highest energy unsuitable intermediate between the reactant and products or get decomposed immediately to give the products. In this state, bonds of reactants are not completely broken while the bonds of products are not completely formed. So here bonds of reactants are not completely broken and bonds of products are not completely, their bond are not formed. And next is this threshold energy, the minimum amount of energy while the reactant must process in order to convert into product is known as threshold energy. So activation energy, the additional amount of energy required by the reactant so that their energy becomes equal to threshold value is known as the activation energy. So EA minus ET minus ER. So after that, important points about Arrhenius equation. So the important point is R2 and R1 are the rate of constant, T2 and T1. Then log K2 by K1 is equal to EA by 2.303 or T2 minus T1 by T1 into T2. So fraction molecule which with energy equal to or greater than the activation energy is called Boltzmann factor, and is given by, it is said like log x is equal to minus EA 2.303 RT, and E is constant for a particular reaction. Here in this reaction E is constant and EA does not depends on temperature, volume, pressure, etc., but gets affected by catalyst it gets affected. Next is role of catalyst in a chemical reaction. So in the chemical reaction, catalyst provides an alternate pathway or reaction mechanism by reducing the activation energy between reactant and product and hence lowering the potential energy barrier as shown in this figure. In this presence of catalyst, activation energy decreases, and Kp and Ka is equal to EA minus Ep RT is equal to E to small a to the power delta E by RT is the formula. And theory of the reaction rates. So collision theory. So according to this theory, the reactants molecules are assumed to be hard spheres, and the reaction is postulated to occur when molecules collide with each other. So this reaction occurs when molecules collide with each other, and the number of collision between the reacting molecules taking place per second unit volume is known as the collision frequency. The collision between reactant molecule for per second unit is called per second per unit volume is called the collision frequency. But only there is a collision in which the colliding species are associated with certain minimum amount of energy and collide in proper orientation result in the product formation. Such collision are called as fruitful collision, or it's also called as effective collision. Next, here collision frequency into fraction of effective collision we have to do to. Next is the activate complex theory or transition state theory. So reactant is equal to activate complex that gives product, and this theory is based on the fact that bond cleavage and bond formation involved in a chemical reaction must occur simultaneously. Hence, the reactants are not converted directly into the products. There is an energy barrier or activated complex between reactants and products thereof, and the reactants must cross this energy barrier before converting the into product. It should cross this. So photochemical reaction, for chemical reaction that occurs on exposed to visible radiation are called as photochemical reaction, and the rate of photochemical reaction is affected by the intensity of light, and temperature has little effect on photochemical reaction. And quantum yield or quantum efficiency of a photochemical reaction is equal to number of reactant molecule reacting in a given time or number of protons of light absorbed in the same time. So this was your chapter, the chemical kinetics. So I have explained all the topics of this chapter. So okay friends, I think you understand this chapter. So like the video, comment on me, subscribe my channel, do things like for more video. I will explain the next chapter in my next video. Till then, take care, have a nice day. Bye my friends.